So welcome back, you guys. We'll take a look at the graph of a function, and we're going to apply function notation to graphs. So given the graph below, what is f of 3? And remember, f of 3 is, what is f of x, you guys? Remember, f of x is a nickname for y. So this is saying, what is f of x, or the y value, when x is 3, right? That's what it's asking. So I look on the graph, I say, well, when x is 3, it's right here. So it looks like my y value is 1, right? That's the 3 comma 1. So it looks like f of 3 is 1. And also, how about this one? What about solve this? What makes this true? Well, if f of x is a nickname for y's, this is saying, what is the x value? So x would be what when y is 4? Well, let's find our y. Here's our y value of 4 right there. So it looks like we actually have two spots right here that makes this true. X could be 0. 0 has the point 4. And x could be 4. So when x is 4, y is also 4. Again, both of those points right there have a y value of 4. So what x value makes that true, such that f of x equals 4, such that y equals 4? All right, let's do a graphical look now, finding a domain. Well, the domain is all set of all x values. So I'm thinking to myself, I'm going from what x value, and notice it encompasses all those x values up until, whoops, and I should say I do not include that x value, but I do have all these x values in between, right? Like -2 is not on the graph, but -1 is on the graph, -1.5 is on the graph, -0.5 x value, 0, and so on. All those x values in between. So from -2 to 2 is my x values, the domain. So if you want to put in set notation, less than 2, greater than -2. So there's our domain on that. How about the range, the set of y values? Now I'm looking vertically. My lowest y value is -1, but I'm not including that. So that's going to be a parenthesis, and it encompasses all these y values, right? See all these y values on the graph? Up until all these y values up until 1. And it looks like I do include 1, so that'll be a bracket. So the lowest y value is -1. Do not include highest y value of 1, bracket. All right, how about intercepts? Well, let's do our x-intercepts first. Here's our first x-intercept. There's our next x-intercept. -1, 1, 0. Now let's do our y-intercept right there at 0, 1 as the y-intercept. Right, these are our x-intercepts up here. All right, let's do this one. Go ahead, find f of -2. So what is the y value, right? In other words, what is y when x is -2? So f of -2 is, when x is -2, we're right there at that point, 1. F of -2 is 1. When x is -2, the y value is 1. All right, let's keep going. What's the x such that f of x equals 3? In other words, when y is 3, what's the x value? When y is 3, what's that x value? So I'm looking at it, I say, well, here's my y value of 3. Oh, there's the point, 5, 3. So x got to be 5. Next question, is f of 3 positive or negative? Well, let's find f of 3. F of 3 is right there, that red dot, right? F of 3 is a, I don't know, -1.8 or something like that. So we would say f of 3 is negative, right? Because it's like the y value is -1.8 or something like that, right? All right, what about the domain? So the domain, what's the furthest left x value that we have? So the leftmost x value is right there. It includes that -4, and then all these x values are included up until 6. You see that one's our rightmost x value. So -4 up to 6 include both points because they're filled in. If you want, you can put that in set notation. All right, let's do the domain. Erase this here. I'm sorry, the range. So the lowest y value is that -2. We include it. We do hit it. It's filled in. And then it looks like it includes all these clear up until this is our highest y value right there, the 3, and it's also filled in. So we go from a -2 low y value up to a high of 3. Both of them are filled in. And now let's answer this question. For which values is f of x positive, greater than 0? For which values is f of x positive? Let's go up here and look. Let me erase this for a minute. For which values is y positive? Well, let me do it in red. I'm all positive here. Now, I have to be positive, so I cannot include that x value. So far, I'm from an x value of -4 up until, right, I include this up until 0, but I do not include that 0. So far, that's the area on the graph that I am positive. -4 up to 0. But there's another part on the graph, so I'm going to say union, or you could put a comma between them as well, or this is also positive on the graph, right? It's above the x-axis. It's positive there. But I have to be above it, so I cannot include those points from 4 to 6. So from 4 to 6 as well. All right, first of all, f of -1, that's that point right there. -1. When x is -1, y is 2. F of -1 is 2. Now, where is y? F of x nickname for y. What x values make this true? Well, right there, -2. You have an x value -2. X could be -2. Right here, x could be 3. And right there, x could be 5. In other words, f of -2 is 0. F of 3 is 0. And f of 5 is also 0. F of -1.5 looks about right there on the graph. It's about 1. About 1, I'm not so sure. But all we care about is it positive or negative? Well, it's positive. It's above the x-axis there. All right, how about our domain? What's our domain? What's the set of all x values? So I'm saying, well, what's my leftmost x value? There's my leftmost x value. It looks like it's at an x of -3, but it's open, right? That's open. So I cannot include the -3. So not include -3, but then all these x values, see all these x values are included up until an x value of 6, and the 6 is closed. So your x's are going from x such that I'm less than or equal to 6, but I'm greater than -3. That's the set of all x values on this. Let's see if I can erase this. Now let's do the range. Now our lowest y value is right here. It does not include it. Don't include that low y value -4 because it's an open. And then it encompasses all this, right? All these y values are encompassed. The highest y value is right there to 4. It includes it. Clear up here to 4. And we include it right there. So looking vertically. So -4, I don't touch that lower point. I do touch a y value of 4 at the highest point. So y is such that I'm less than or equal to 4 and greater than, -4. Okay, now let's do the x and y intercepts. So notice the x-intercepts right here, -2, 0, 3, 0, and 5, 0 are all the x-intercepts. and then the y-intercept is right there, 0, 3. Right? So let's put those down here. -2, 0, 3, 0, 5, 0, 0, 3. There's our x and y intercepts. All right, let's move on to this one here. Determine whether the graph below is that of a function by using the vertical line test. So let's run the vertical line test. It can only hit once, hits once, hits once. Okay, for every x, there's only one y. So yes, it is a function. If it is, find the domain. Well, it doesn't have arrows on this, but notice it keeps going. This is just a rip from a graphing calculator, and this keeps going, right? So they keep going. Can you tell? I know it's going down quick, but it's also going left. Very slowly, but it is going left. In other words, if you were to pick this point out here at -4, it's like way down here, but it is on the graph, right? It's somewhere on the graph. It's just that it's way, way down there. So it keeps going left. So this domain is coming from -infinity because it keeps going left, and that thing just keeps going right very slowly, but it does keep going right. So it's all real x such that x is an element of the real numbers. Now, what's the lowest? Let's do the range. Well, the lowest, remember, this keeps going, right? So there is no lowest. So it comes from -infinity up to, it looks like the highest y values are right there. It hits it on both sides, a y value of 1. So in other words, y such that y is less than or equal to 1 is your range on that. Let's do the intercepts. There's 1. There's 1. So my intercepts are in black there. -1, 0, 1, 0. And then the y-intercept, right, this is the x-intercepts. The y-intercept is 0, 0. Right there in the middle. Now, lastly, do we have any symmetry? Do we have any symmetry? Is this reflective? Well, if it's reflective about the x-axis, then this point would be right here down here if it was reflective about the x-axis. It's not on the graph. So it's not reflective about the x-axis. Let's see if it's reflective about the y-axis. If this point here is reflective about the y-axis, it would be right here. If this point here reflected about the y-axis, it'd be so on. So every point is. So this is symmetric with respect to the y-axis. If it was symmetric with respect to the x-axis, then the points would flip-flop around both axes, which it does not. So we're all done. All done with that one. All right, I think that's my last problem. It is. Thanks so much for watching. See you guys next time.